Hello dear friends, and welcome once more to another video in our YouTube channel. In this video, friends, we shall be looking at this question I have here on screen, friends. It's probably a question in 2019. The question which is that to show that that the function f is defined by f of x equal to 2 over x squared minus 1. The a part wants us to express f of x in partial fractions and show that the definite integral going from 2 to 3 of f of x dx is the same like the natural log of 4 over 3. And the next part wants us to find the integral of cos cube of x sine cube of x dx. So friends, please share the video out with your friends so that they can access to contents like this that can help them in their own exams. Thank you so much, guys. And it took me quite a lot of time, guys, to actually present this content for you. So please consider subscribing to the channel and giving the video a like, because there are so many contents in our channel that you can only have access to them once you've subscribed. Thank you so much, guys, and let's dive straight into our video today. Great, friends, great. Here's the question we have here on screen. So friends, I think we should go straight to the point. Okay, let's just go straight to the point. This is what we have. They want us to express this 2 over x squared minus 1 in partial fractions. So friends, we see that it looks pretty scary, right? It looks pretty scary. So we are going to try to factor out the bottom. Since we can recognize the bottom as the difference of two squares, we are going to have this equal to 2 over 1 over x plus 1 into x minus 1. That is when we express the denominator as a difference of two squares. Now at this point now, guys, we are ready now to express in partial fractions. By so doing, guys, since all the denominators are linear factors, that therefore means that all we are going to have up are constants. Okay, so we are now going to have a constant. We can call that constant p. Initially we have been using a, right? Let's use p in this case. We are going to have p over the first factor, which is x plus 1, plus cure over the second factor, which is x minus 1. Good. So guys, we are going to multiply this whole equation now by the LCM, and the LCM in this case is x plus 1 into x minus 1. So multiplying it here, guys, the x plus 1 will cancel the x plus 1. We are just going to have p into x minus 1 plus cure into x plus 1. That is identically equal to 2. Good. That is so because the x minus 1 will also cancel and give us cure into x plus 1. Then since x plus 1 into x minus 1 is our LCM here, is going to cancel with the one that is being divided by 2. Good. So guys, in this case now, all we need to do is to solve for the values of p and cure. So we are going to let our x equal to 1. When x equal to 1, guys, we plug in the 1 into all of this our equation. We see that the term containing p is going to cancel, right? Because it gives us 0. Then the one that has to do with cure, we are definitely going to have 2 cure, because if you plug in 2 here, guys, you're going to have, you plug in 1, sorry, you're going to have 1 plus 1, which is 2. Then we have 2 cure, which is equal to 2. At this point, guys, you can use your equal to signs. It is the same. Okay, at this point now, it is now an equation, not an identity anymore. So we are now going to have our cure in this case to be 1. That is when we divide all through by 2, we are going to have cure to be 1. Good. So friends, now if we now put our x to be negative 1, here we are going to have negative 2p, but here we are going to have 0. Since negative 1 plus 1 is 0, so we are going to have negative 2p here. That is equal to 2. That therefore implies, guys, solving for p, we have p to be negative 1. Good. So friends, now this f of x that we have here, which we just factored. Okay, this f of x, which is equal to what we just factored, the denominator, is identically equal to what, guys? Our p is 1, m is negative 1, sorry. That's why we have negative 1 over x plus 1. Then our q is 1 plus 1 over x minus 1. Good. So friends, that's it. Then the next part is saying that we should show that the integral going from 3 to 5 of f of x dx is like natural log of 4 over 3. Good. So friends, that is, they want us to show that the integral of this f of x is the same like what we have. So friends, let's know that this integral from 3 to 5 of f of x dx, guys, is the same like the integral going from 3 to 5. Our f of x is what we express in partial fractions, which is just it here that we have. Then friends, since all the denominators are linear, guys, it becomes very easy. Okay, because to integrate a linear factor, we are just going to have the natural log of that factor. okay, we have the natural log of the denominator. So since this is negative 1 at the top, we are going to have the negative 1 times the natural log of the absolute value. Guys, keep in mind absolute value signs, because we must take care that what should be inside the natural log should not be negative or 0. It should be greater than 0. So we have negative natural log of x plus 1, then now plus the natural log now of x minus 1. Good. Under normal circumstances, guys, we have to divide by a derivative of the bottom, but since the derivative of x plus 1 and x minus 1 are both 1, we don't need to bother. So the limits the limit will be going from 3 to 5. Good. As we have. Great. So for instance, now if we plug in everything, now that's all we have to do to plug in everything. We are going to have plug in 5 into this our guy. We are going to have negative natural log of 6. Then now plus plugging in 5, we are going to have 5 minus 1, which is 4. Then minus the upper limit, that is minus, if we plug in 3 here, we're going to have 4. But minus, because upper limit minus lower limit, that is all of this guy minus this guy gives us positive. That's why we have ln 4. Then now plugging in 3, we're going to have 3 minus 2, 3 minus 1, which gives us 2. We have minus ln 2. Good. So friends, if we simplify, so we are definitely going to have the natural log of 2 over 3. That is so because, guys, we have a negative here and we have a positive here, right? Good. But this ln 4 and this ln 4 can give us what, guys? Can give us ln 8, right? Then if we not take 8 over 6, that is the property of logarithms, we have 8 over 6. We simplify, we're going to have that is, guys, multiplying these two guys, that is, if you add the 2 of them, right, we are going to have 2 ln 8, right? Good. We are going to have 2 ln 8. Then now, guys, if you since there's 2 ln 8 here, right, since there's 2 ln 4 here, right, then this minus ln 2 here, we can simply simplify the right hand side, and we can simply simplify it so well. We are going to see that we are going to have the natural log of 2 over 3 plus ln 2. Keep in mind, friends, that if we decide to even express this ln 4 as 2 ln 2, right, because we can look at this 4 as 2 squared, the square can come in front. We are going to have 2 ln 2 minus ln 2 simply gives us ln 2, right? Good. Then we have this ln 4 here, and we have this our negative ln 6. We can divide this 4 by 6. We are going to have ln 3, then now plus the ln 2 that we have. Then now if we just simply apply our law of logarithm, that is by when we have addition, we simply multiply their interior. So we are now going to have the natural log of 2 over 3 times 2, and this just gives us our proof as we have as natural log of 4 over 3. Great. So that's the end of the proof, guys. That's the end. So friends, please like the video. Friends, please put in the comment section down below if there's something you found, if there's something you do not understand, guys, and I'm going to explain clearly for you. Thank you so much, and share it out with your friends, please. Okay, now guys, the next part wants us to evaluate the integral of cos cube of x sine cube of x dx. So in this case, friends, our integral looks pretty crazy, because we have a product of two functions, but we cannot use integration by parts since the derivative of one will not give us the other unless we do some u sub. Okay, that's right, I just said the method right. Okay, we're going to be using the u substitution. But before then, guys, we are going to express cos cube x as cos, as the integral of, we have cos x times cos squared of x sine cube x dx, because if you multiply these guys, you are going to have back what you have here. Good. Then friends, we are going to express this, we are going to try to express everything in terms of sine only. Okay, we are going to express this cos square x in terms of sine only, then this cos x we are going to allow it. Good. So friends, we are going to express cos squared x as, so guys, let's note here, let's note the identity for cos squared x. Let's know that cos squared x, guys, is given as 1 minus sine squared x. Okay, that's from the formula sine squared x plus cos squared x equal to 1. So if we plug in everything here, guys, we plug in our cos squared x by 1 minus sine squared x, we're going to have the integral of cos x is here. 1 cos squared x is like 1 minus sine squared x according to what we have here. Then we have sine cube x. If we multiply out this sine cube x inside the bracket, we are going to have the integral of sine cube x minus sine to the power 5x cosine of x dx.
So guys, if we let our u now to be sine x, such that the u gives us cosine of x dx, and guys, you can see that what we have outside here is what? Cosine of x dx, right? And that is just our du, right? Hope you understood, guys. Put in the comment section down below if there's something you didn't understand, and I'm going to explain in very clear detail for you. Hence, we are now going to have our integral of our, keep in mind our sine x was what? U, right? So we have u to the power 3 minus u to the power 5 cos x dx, our du. Good. So friends, if we just simply do our normal integration, normal reverse chain rule, normal product rule, we are just going to add 1 to the power and divide by the new power. Adding 1 to 3 gives us u to the power 4. Dividing by that, we have 1 over 4. Minus adding 1 to 5 gives us 6. Dividing by that, we have 1/6. Then since we are done integrating, guys, we have plus c. That is the answer, guys. But we have to leave from the x word back to the, since this is an indefinite integral. Keep in mind that our u is what? Sine x. Good. So we are just going to have 1 over 4 sine to the power 4x minus 1 over 6 sine to the power 6x plus c. Thank you so much, guys, for watching the video. Thank you so much, and see you in my next video. Stay safe, guys, and have a day and good luck as you prepare for your exam.